Welcome to another video. Today we're going to look at something very interesting that happened over the weekend. Some of you guys know I like electric vehicles and converting classic cars to electric vehicles. And I realized that the battery in one of my cars was draining. And the first thing that I looked into was what was going on with the contactor, right? Because if the contactor is not working properly, we end up with the high voltage always connected to the motor, thus over time draining the battery. And that's what I found. The battery is completely drained. So doing a quick check here, getting my multimeter, you're going to see that this contactor, even when not powered, is always shorted, right? Here's a good contactor on the left. And as you can see, when I don't have any power, you don't have a connection. Here, it's always connected. So I put this LED here, so what we're going to do now, you're going to see that when I power the two contactors and they're connected together, I'm going to power them with 12 volts. You can see them both click, so they're both energized. The good one here on the left is working properly. The one on the right is also on. So this guy here is always on, and I don't really know why, right? It might have been a peak of current that ended up basically welding, right, the two poles of the contactor to the contact bar. Let's go to the whiteboard and figure out exactly how a contactor works. So we're going to show you a drawing, a little sketch of the cross-section of the contactor with the two poles here on the top and a solenoid that moves this contact bar up and down. And after we do that, we're going to go downstairs and X-ray and figure out exactly what happened. So how does a contactor work? It's fairly simple. You apply a low voltage into the solenoid, right? So between 12 and 48 volts, depending on the low voltage required by the car. That low voltage creates an electromagnetic field that pushes this shaft up. And this shaft is connected to this contact bar. The contact bar, once energized, the shaft pushes up, the contact bar then makes a connection between the two sides of the contactor, right? Thus creating a short between those 2 points. Once you remove the voltage, the contact bar drops. There's a spring that pushes it back, opening the contact. The issue we're having here, like you saw, is that this bar is always up, right? And that can be caused by an overcurrent that basically welded those 2 points to the contact bar. So we can hear the contactor, the solenoid clicking on and off, but the bar is not moving up and down, thus creating the issue that we're seeing. You see, that's why I love working at an X-ray company, because we can take those devices, bring it here and see what's inside, no matter how much encapsulation is around these contactors. So let's check it out. Let me turn on the X-ray here, and we'll be able to see the construction of the contactor from inside out. So as you can see here, this is the contactor bar, and these are the two poles, the two sides of the contactor that close the circuit on your high voltage device like your electric vehicle, right? I can move this a little bit to the left here, and you can see the, the screw and the nuts that connect to your high voltage cables. So this is what a good contactor looks like. Right now the contact bar is open, and when I apply 12 volts to the solenoid, the shaft is going to push this contact bar, closing this circuit here between this and the other pole. So let's do that. Let me connect to the 12 volts, and as you can see, we close the contact. Let me do it again a couple more times so you can see. Now it's open, so I de-energize or remove the 12 volts from the solenoid. Now I'm going to put it back. As you can see, we close the circuit here on the contact bar. So let's see what's happening with the bad contactor, the one that I showed you earlier. It's not working, it's always closed, right? So for some reason, there is weld, if you will, that contact between those two sides of the contactor. So let's move it here, and there you go. Check that out. You see the contact bar here? It's basically fused onto the two poles. And interesting enough, the shaft, the solenoid still works, and I'm going to show you here now. I'm going to apply the 12 volts, and you can see that the shaft's still moving up and down, but the contact bar is now just welded to the two poles, thus creating this short that doesn't go away. Now, some mechanical shock, we've been able to drop this on the floor, and that mechanical metallurgic connection breaks free, and we get the contactor back working. But again, wouldn't be a reliable connection you're going to put in your car or your solar installation, right? It's probably a contactor you're not going to be using anymore. But anyway, hope this was interesting to understand how a contactor works and how it doesn't work, right? How a high current event can cause the contact bar to fuse between the two poles, thus rendering the contactor unusable. Thanks for watching, and don't forget to subscribe. See you next time.